Okay, so in the last stream, I guess I'm live. Am I live? Hello? Yes, I am. Okay, so in the last stream, we implemented the dynamic array that will be needed in this stream. Um, so today we will implement the compiler backend. So what does a compiler do? It converts a high level programming language to a lower level language. That may be binary, that may be assembly, that may be an intermediate. So in modern days, the compiler are divided into two stages, like the front end and the back end. The front end takes the high level language and tokenizes it and parses it and turns it into an intermediate language that is easy to optimize and do stuff. And there is a backend that turns that intermediate language to the target language. That may be machine language, that is binary, or that may be assembly. So for our purpose, we will implement a very basic virtual machine that is very simple. It can perform very basic operations like addition, subtraction, and we will under the hood we will use the C library. That is, the virtual machine will run whenever it faces an operation. It will call some C function under the hood. So our virtual machine will be written in C. So let's implement the virtual machine today. So we have in the last stream, if you know, we have implemented the dynamic array of integers. So let's take this code like this: integer array, dynamic array, and make it in let's just take it in another file, that is dynamic array.c. Let's call it integer dynamic array. Frutada. Okay, so we will copy some code from the previous stream. We will make a dynamic array for 3 data, like for integers, for floats, and for bytes, because they will be needed. We can do some macro magic that will generate the code for us, but let's keep it simple. We will write 3 files: int dynamic array, float dynamic array, and also byte dynamic array. Everything will be same in this 3 file, just this part, this int start data, that will be float start in float dynamic array and byte start in byte dynamic array. Everything will be exactly same. So let's just change this to float. This will hold some float values, and it can be dynamically allocated and deallocated. Let's call it float r. And we also have to change all these occurrences. Let's just find and replace. We will all change this to floater. I cannot see whoever is watching, man. Okay, now it's good. Cannot see the chat. Let's replace all those things. Okay, so where is the error? Okay, we have to include the header files. Easy peasy. stdlib and also stdio, I guess. IO. Okay, so it seems the errors are gone. Also, we have to change that malloc part. We have to make it, we have to cast it to float star, because malloc returns a void star pointer. When we are gonna access it, there will be some problem if we don't cast it to float star. Okay, and also the delete part. In the delete part, I'm not deallocating, but it's just fine for now. It was challenge for you guys. If you have done it, let me know in the comment. If you have done the shrinking part, that will be in this delete float air. That will be this realloc part. Also, we have to cast it here. Realloc also returns void star, so let's just cast it to float star. And and there was a bug in the code. If you haven't noticed, in the previous stream we didn't multiply it with the size of int. Realloc or any kind of allocation data takes input of the in a byte form, like how many bytes we have to allocate. So if we want to allocate 5 floats, so we have to 5 into size of floats, so it will be also float, and it will be also float. Okay, float is fine. Okay, our compiler will be very simple. It will in like JavaScript, it will have the value data type, and the value will be just float, real integer. There will be no integer or float or anything. So okay, the integer parts also we have to include the header files. Just copy paste it. I can't type that much. Fine. Integer, the integer file is okay, and we have to copy it in the byte array. Now the byte part is interesting. Byte, you have to okay, you have to, here you don't have to give size of int or whatever. The array start will itself will be the size of byte, the 4 bytes. So it is taking input 4. So malloc 4 will allocate 4 bytes. So no need to multiply or anything. Okay, and also here we have to new capacity. Let's just cast it to byte. Here byte, in C, byte is character, and that is 1 byte. 1 byte, it has 8 bits, so it can hold 0 to 255 if it is unsigned, or if it's signed, that is -127 to -128 to 127. That is the character limits. Okay, so I guess it is fine. It is fine. Malloc, we have to cast it also, char star. If you like notice any bugs or anything, please let me know in the comment. If I forget to do anything, if you want to incorporate anything, I'm doing whatever I can. Okay, char star, okay, float, okay, and also okay, that is fine. In the main.c file, let's just this ripple function and execute function that we have written. It was very rudimentary. It was like very what should I say? It was nothing. So let's just here there will be only ripple function. Let's just take it this to the VM, that is virtual machine. We will implement the virtual machine today. Okay. So the virtual machine, it will be like a CPU that will be simulated in the computer. It can execute various kinds of operations. We will define those operations. Let us just do that. So let's make a struct. Let's make a struct that is machine. It will be our machine. So struct. So inside the machine, what will be the data? Okay, so let's just keep it simple. In the laptop or any kind of machine, there is a CPU. In the CPUs, there are various kinds of registers, small memories that is very fast, and the CPU work on that. Like if we say add some register to some register, it can do, like let's say there is a command, like let's just say add the CPU registers have names like RXA or EAX, EAB, EAX and EBX. There are various kinds of naming convention, like E for extended. So let's just not go into the details. Let's say there is an operation add EAX to EBX. So the CPU, what it will do, that it will add the EAX to the EBX. And in all of the CPU, there is a common register, that is instruction pointer. So in our machine, there will be instruction pointer. Let's just call it IP, instruction pointer. What is instruction pointer? Instruction pointer always points to the next instruction that we are going to execute. It always points. So whenever we are executing some instruction, the instruction pointer always points to the next instruction that we are going to execute. It will be clear when we implement it. So what will be its data type? Instruction pointer, let's just keep it for integer. And this struct, let's call it machine. And okay, sorry, my syntax is incorrect. And also type defect. Okay, so our machine is very simple. It has only an instruction pointer, but what does it point? So let's call it a struct, another struct, code chunk. You know what, let's just define the opcodes, like just a rough ops dot. So in our compiler, in the backend, the code it generates, what will be the operations that we are going to perform. So we can perform addition. So that will be ADD. Let's just keep it in capital, ADD. It can perform subtraction. It can perform multiplication, it can perform division, it can perform negation. Negation means if I say negate some value, it will just multiply it by -1. Okay. Let's keep it at that. 5 operations. We are gonna extend it later. Let's just, so the code chunk, it will be also a struct, and it is gonna hold a byte array, that is byte dynamic array. So also we have to include it, let's just not include it because this is presently it is on C. So let's just what was the name? Byte array. Oh, we didn't change the name. Byte array. Also we have to change all the names. Let's just call it byte array. Change all occurrences. Okay. No errors, I guess. Fine. Now here, this is code chunk. So a code chunk has code that is a dynamic array, byte dynamic array, and we can call it byte array for now. Okay, so it has code byte array. How it gonna look? See, the byte array gonna look like this, like the code it generates. Like say maybe add. Oh, also we have to load and load. It has to be an operation. What load does? Load just takes the value from the stack. We also have to include the stack. It will be a stack based virtual machine. Stack. We have to implement the stack also, and in the stack there will be some in the stack it will be value. And what will be value? Value are just floats. We called it value will be just floats. Type def float value. Okay. Also we have to implement the stack. Implementing the stack is very easy. Let's just implement the stack. Inside that there will be a float array and also a top. Okay. In the stack there we can just do 2 operations, a push and a pop. So let's just implement this 2 function. Void push. Okay, there's a stack. You know what? We shouldn't segregate these codes. Let's just keep it in a single file, because there is too much errors going on. Let's just keep it in main. It was a mistake. Float array, enter and byte. Okay, let's just delete these three files. Okay. I hope there is no okay. Here just and the float array stops here. And also the byte array stops here. Looking good. Just open the outline. We can navigate on here. Okay. Fine. Now, where were we? Where is the machine part? This is byte array. This is float array, and also this is integer array. Okay. Is anybody watching? Let me know in the comments if you watch it. I hope anyone is not watching. Okay. Okay. It seems I have deleted the machine part. So let's just write it again. Struct machine. Inside this there will be a code chunk that will be chunk. So let's define what is a code chunk. Struct code chunk. Inside here it will be a code chunk. Inside it there will be byte array. Code working fine. Inside the machine there will be instruction pointer, that will be an integer. It will be code chunk star. Variable code chunk type def, we have to type def it, and also we have to type def it. Okay. In the code chunk there will be code, and what is code part? It will be an array of bytes. In the bytes, in the code, what will there be? Okay, let's just declare a enum. Inside that there will be op add, op sub, op mul for multiplying, op division. These are all operations. Op negation, and also op load, and also op constant. The constant operation means that after this operation there will be a value. In a code there are whenever we compile something into a machine code, there is not only just the operations, there is also value. Let's just say we are writing a code that prints hello world. Okay, so we are providing that hello world in the code, so that's constant data and it is there in the code. So that means we have to write some operation for that part also, that if the virtual machine faces this op constant, it will know that after this there is a value, that is data. And in the machine, in the code chunk, we have to also have an array for that value, or we can say data. What is the problem? Invalid combination of type specifiers. Okay, here I guess machine derived struct code chunk, invalid combination of type specifiers. What is this? Okay, semicolon. It is always a semicolon. My god, man. Anyway, so okay, in the code chunk, so let's just test it. Write small chunk of codes and always test it, because when you write a big like a page full of code and nothing is working, you can't know what is wrong. Okay, so let's just make a code chunk in like statically. Code chunk. My naming is very awesome, superior. Code chunk. That is awesome, bhai. So chunk. Let's initialize that chunk. Okay, so for that code chunk, we have to write the initializer function. Init code chunk. It will do nothing. Void. It will return nothing. Init code chunk. It will take that pointer. Code chunk star chunk. So what will it do? Okay, it will initialize that byte array and that float array. Okay, so init byte array chunk code and init float array chunk data. Okay, is anybody watching? If you are watching, please write your name in the comments so that I can know. I would be obliged. Okay, so okay, so in the machine we have to also have to have a stack. So let's just make a stack. Implementing a stack is very easy if you have dynamic array. Struct stack, also type def. You know the drill. Stack, there will be okay, so the stack will hold values, so it will be a float array, float dynamic array, float array data, and for every stack there is a top, we know, so it will be an integer top. The top will track what is the last value. It will increase and it will decrease. If I guess we can omit the top, because in the data there is a length function. Okay, so push void push stack. What will it receive? It will receive a stack pointer, stack star stack, and nothing. Oh, and the value also, and it will be a float v. It will boost that value in the stack. Okay, so what we can use that function add float array. It will just, we will provide that stack invalid combination of type specifier stack. Okay, stack data, and we have to pass it the pointer of it. We have to pass the value. I guess we are done. The push function implemented. How awesome is that? We have to implement the pop function. Pop will return a value, and that will be a float. Pop stack. It will also receive a stack pointer, and Now comes the interesting part. Pop. Now pop can fail. A push won't fail unless the memory is full, your computer memory is full. A push cannot fail because it is dynamic array. We can always make some space in this data and can be pushed. But pop can fail. If there is no data in the stack, what will we do? We will return 0, that is for sure. But let's say the constant is 0, like the value it is returning, and like originally there was 0 and it is returning 0. So how will we distinguish these two events? That it is returning 0 for there is nothing in the stack, and it is returning 0 because the value is 0. So we will, I guess, we will not return a float, we will return a bool, and we will accept a float pointer that will act as a bucket. We will put that value on the float, like the pointer. We will dereference it and put that value on the float. So float bucket, float star bucket. So I guess I'm clear about what we are doing here. The bool will be true if the value is like legit, and the bool will be false if there is no value in the stack, when we are just returning 0 as like just officially. Anyway, so let's just check the length of the if stack data. Okay, identifier bool is undefined. Oh, okay. So let's just, okay, in C there is no boolean. Sad. Let's just call it integer. We will return 0 if okay, we have defined true and false 0. We haven't yet defined it. So let's just define true 1 and define false for 0. That is, true will be translated to 1 and false will be translated to 0. Okay, so where were we? Pop. Okay, in the pop we will return integer. Okay, now let's just say if the stack, inside the stack there is data, that this data is the dynamic array part. So that data has a length okay, what is happening? Expected. Oh, we have to do bracket stack data. Why it is not giving me autocomplete? What is happening? Okay, struct instead of a pointer. Okay, let's just call it length. If it is 0, we will return false. Also, we will dereference the bucket. I hope you know what is dereferencing. That is, if I accept a pointer, so whoever is calling this function will provide a pointer to some variable in their stack, like their stack space. We will just dereference it, that is, we will access that memory that is in the caller function, and we will put something in there. So we'll put 0. Modifiable L value. Oh, and bucket, no start bucket. Okay, dereferencing is star, I'm sorry, and takes the reference. Okay, data dot, it will be dot, yeah, dot length. Fine. So see, the stack is a pointer. We will stack arrow data. This is this function, and this is actually the struct. This is not a pointer, so we have to dereference it by dot. Fine. Okay. So if there is nothing in the stack, we will just return false and put 0 in the bucket. If it's not 0, then we will return that value and decrease length by 1. Okay. So if it's not, star bucket will be stack data dot data length -1. You know, the length was pointing to the last data, I mean the position after the last data. So the last data will be length -1. And we have to not first bracket, it will be third bracket. The bucket should be fine. Now we have to decrease the length by 1. You know, we should write another function for this kind of thing, but it's unless you are copying at least thrice in a code, don't make a function. It is bad practice. If you have to just write some difficult code, that is fine. If I have to write this 3 times in a row, then I will make it another function and we will simplify this kind of thing. For now it is fine. Start bucket equal to will be that, and we will return to true. Also we have to decrease the length. Stack data dot length -. Okay, return true. I hope it is fine. Okay, in the machine, let's just define a stack. Stack. Okay. Okay. Now, chunk. What is admin byte array is incompatible with parameter of byte start. Okay. Chunk of code. We have to pass the pointer. We just pass the pointer. We pointed. Okay. Now let's debug. Write a debugging function. We can debug a code chunk. Void debug code chunk. It will also okay, it is fine. Chunk. Okay, what is there in the debug chunk? How do we do that enumeration as byte? Okay, so let's just we will write a for loop, and we will write all the code there is present in the code chunk, that is in the chunk. We will write all the array elements of this code and also the array elements of that data. Okay, so what will be count? That is chunk code dot length. I will run from 0 to length -1. Fine. Okay, let's just printf for now. Percentile is, I guess, no, and it is D for now, D, and we will chunk code dot data I, no, data dot the code is a byte array. The byte array is data. It's data I. Fine. Let's just debug a code chunk. Okay. Now what will be a chunk look like? Also, we have to write another two functions, that is appending a code and appending a value, I guess. Okay, so void append code chunk. It will receive the code chunk star chunk, and it will receive an enumeration. Let's just call this. How can we write an enumeration in C? How does it behave? Let's just see. Enum C enum level. Okay, so let's just call this opcode. Opcode, is it a good name? OPCOD, opcode, that is fine. So it will receive, it will receive a opcode OP. We have to type def it so that we don't have to write enum every time we say opcode. Nice. Okay, so we will just push or like add byte array. Chunk code and OP. Guess that's gonna work. Byte array is incompatible with parameter byte array star. We have to pass the pointer. I guess that's fine. OP. Until and unless these opcodes are greater than 255, there will not be any problem, because this byte array, it can hold only 0 to 255. So I guess we are fine. Add float array. Okay, let's just demarcate here stack. Where is stack ending? Here it is ending. Okay. Is anybody watching? Still not anybody watching. No issue. No issue. The machine should be here. Okay, this execute function, we have to rewrite it. It should receive a machine's pointer and a code chunk pointer. And it should do something. Okay. And the ripple also execute. Okay. It should also take that machine pointer. And when for now null is fine. Okay. If code chunk, sorry, if chunk null, just do nothing, return. Execute should return something, but we will do it later. Okay. The stack should be up on after this dynamic array, I guess. Machine. Okay. So in the chunk, let's append some code. OP constant after the constant we should also write an append data. Append data in the code chunk. It will return the index of that data, that where it will put the data, and that we will use in the code. In the code, when we in this op constant, after this, not there won't be the value itself, but the index of that value. And what is the index? That is, in the code chunk, the actual value will reside in this data array, and in the code the index will be there. That is the, I will give an example, you will understand. Okay, let's just do this. In the append data, it will code chunk, and it will accept a, sorry, where am I writing? And it will accept a value, float value. It will add float array chunk data. We will provide the data part of that chunk data. What is it? The data is a float array. The address of it and the value. Okay. Then the add float array, does it return something? It doesn't returning something. Okay. Should we add this add function? Should it return something, or we will access the data directly? Let's just for now access the data directly. Where is it? Append data. Okay, we have appended the value. We will now take the index of that value, and that index will be length minus what it will be. It will be the length is pointing to the next one, so length minus 1 returned chunk data dot length minus 1. Okay, now we will chunk. Here we will call that append data function, and we will let's just say we are appending 45. Okay, now what it is doing, follow very carefully. This 45 is going to this data array, not the code array. It is going to the data array. See, appending data, it is appending to the data array, the data of that chunk, and it is returning the index where, let's just if I could draw it would have been better. In the next stream I may arrange a drawing, something like it will be good to understand, or like visualizing. For now I hope you understand what it is doing. Okay, and also we will repeat it. We will put two constant in the code chunk, 36, let's just say 36, and then we will append a addition operation, op add, and then also we have to, let's just this load, these are two same operation. Let's just say load constant, and there should be another return. What will return do? It will just give it back the result. op constant, it will not be constant, it is op load constant. Fine, load constant. op add, then we will return. Fine. Now what will the code look like? Let's just run down. The code will look like the code chunk. First there will be op load constant. Then there will be, we are appending 45. So 45, the index of that 45 will be 0. So here it will be 0. Then another op load constant. Then we are appending the 36, and the index of this 36, when it is appended to that through this data array, it will be 1. If we like track the data array also, it will be 45, then 45, 36. Okay. Now there is add, so op add, and then op return. So what it should return? It should return 45 plus 36. That will be 181. It should return 81. Okay, let's see if it's at least printing right. We haven't written the execution code at till that this execute function will do all these things. But let's just test. Let's just debug code chunk, and let's just chunk. Let's see if it prints that thing. Okay. Most probably we will get a seg fault because that is so common. But let's just see. Errors. Fine. Compiler error is good, but runtime error is bad for your health, because it will make you anxious. Okay, see what it's saying. Format the, okay, so that's fine. 85. Let's go to 85. Printf, what is doing? Split float array. Okay, so here it will be F, or we can say G. Then just compile it again. What is it? Okay, is it happening something? Moment of truth. Okay, unknown type name code chunk. Why? I haven't type defed it. Of course, koi. Where is code chunk? Here is code chunk. Okay, we have to take it to the top, I guess. Let's just make this let's just take this whole block of code before the machine part. Where is the machine? Okay, machine. Also the opcode part. See, the C compiler is very, very idiot. Like, it just goes from top to bottom. If it doesn't recognize any kind of symbol, it just panics. Like, I don't know this symbol, but it's there. But it panics. It do all of the task in a single pass. So C compiler is a little idiotic. Modern compiler should not do this. Modern compiler should do 2 or 3 passes at least. In the first pass, collect all the data, collect everything what is there in the code. Then in the second pass, then start to do thing. But the C compiler have to do everything in one pass. Fucking idiot. Anyway, so opcode. Just fine. Wait, it compiled. Yes, we are getting segmentation fault. Nice. Why? We are initializing it. We are initialized it. Okay, right? We are initialized byte array and float array. Then we are appending add byte array, add float array. Okay, let's just array start this, change this to 124. Compiled. Still seg fault. Where is the seg faulting? Okay, let's just debug it. GDB. If you don't know how to debug your code, it's a fine start. Let's just run it with the GDB. See. Okay, no debugging symbol found. We have to compile with the -G flag, unless -G, so it will include the symbols so that we can debug. Now GDB. Nice. Let's just run it. If you press R, it will start running. Enable debug in 4D for this session. Yes. Okay. Seg faulting where? Add data, add length. Okay, where is it? 143. See, it was that easy. It should be it should not be length, because length is, where is 143? Add byte array. Okay, what is doing? Okay, see, in the, that is the error. It should be character. Now I guess should do fine. Let's just compile it again. Run it. Still, array is, this value is 5005. Okay, what is the issue? Array data length. Okay, what is the issue? So the problem is happening here. Segfault means we are accessing some illegal memory. So what is happening? Okay, so let's use the inbuilt debugger. Okay, see. Okay, the length is some garbage value. Why is the length garbage value? Okay, we have to deep dive into the initializer function. We are accepting the array. The data part will cat star malloc start. Length is 0. We are initializing it, right? Oh, we haven't initialized the chunk. Fuck, man. See, it should mitigate the error, I guess. Who is watching? One person is like, who is watching? I'm very curious. Can you please state your name? Who is watching? Anybody? Nobody is watching? Okay. So let's just run it again. Well, it exited normally. Now let's run it. See, now comes the fun part. When we are printing the code chunk, let's just give a new line here. And it should work fine. Five 505106. See, this 5 is the enumeration value. Okay, where is the opcodes? Okay, we are load constant. There, the first operation is load constant. So 0, 1, 2, 3, 4, 5. So the load constant is fifth value. So 5, then 0. 0, that is the index, what we discussed. 45 is appended to that data array. Okay, so let's just, when debugging, let's just print all the things. Debug print byte array chunk code, and we should give it the pointer, and also print the code array. Sorry, code array, no, not float array. And we should give it the data. Okay, let's compile it. See, watch the data carefully. If this is the code chunk, the 505106, 0 means we are adding it, because see, if the opcode, where is the opcode? op add is 0, its enumeration value is 0, so it is 0. And also so this is the data. This is the data 45 and 36. See, it's there. We are just keeping the reference to that, keeping the reference in the code part, 505106. Fine. So code chunk part is done. Holy shit. Okay, now let's implement the execute. Okay, so when we load something, we just push that value into the stack. So let's just write a switch function. Also we have to write a for loop first, because we have to execute the entire code chunk. So for code chunk, I start from 0, I will run from chunk code dot length it will run the entire code chunk. Okay. So let's take the OP, and that OP will be character. And we will chunk code dot data. You know what? Because this data is confusing. In the code chunk part, let's call it static data or data word constants float array. What should we name it? Because data is very generic. In the code part, in the code chunk there is code and there is, let's just try constants. Let's rename it by the VS Code renaming operation. Oh shit, not that. Okay, fine. Execute. Where is execute? Okay. So we collected the operation. Now we will run a switch case, and it will run it on OP. So if OP is OP add, let's just load constant. If OP is OP loads constant, we are simply gonna push the constant. So push stack machine stack. We will pass the pointer to that stack and push the value. And what will be the value? See, when we have got a OP load constant operation, we know that the next operation, the next like code line will be that index to that constant. So let's just collect it. Int index. It will be the next value. So let's just copy it. I plus 1. So index will be it, and then we can access that constant. How? We'll just access the constant array. So code chunk, constants dot data index. Fine. We will just simply push this, and also we have to skip the next line. So we will just here I equal to I plus 1, so that we don't, like, if we got the OP load constant, the next line is just the index of the constant value. We have to skip it, or else like in the next iteration of that for loop. In the OP, there will be the index of that value. We don't want that. We want always some, we want these things, this enumeration values in this OP variable. So we have to skip it this. Okay. Load constant done. If we, let's just handle the simple cases first. If we got the OP return, we will just pop it. We'll print the stack. We will just pop the stack and print the value we have got. So pop stack. Okay, so we have to provide the bucket also. We will just do that. Just okay, you know what? It's a bad idea to like do this like this. Just do it incrementally. Let's make a float variable good nice bucket and make it 0, and we will write int all okay. That will be equal to pop stack, and we will give this pointer machine stack. Okay, so this stack is done, and we have to provide the bucket also. Bucket we have provided. Now we will check if all okay. If all okay, if not all okay. If all okay, then we will go to the next line. If not all okay, if all okay is false, if all okay double equal to false, and you know what, whenever you are like comparing a boolean value, just omit the boolean value, and here just make this not all okay. All okay will be true if it is all okay. If not all okay, then we will exit. If not all okay, or exit, not exit. Okay, just exit for now. Print something. Print stack is empty. Stack. Sorry, the pop stack. Where am I writing? Fucking shit. Pop stack didn't work. Didn't work. It's fine for now, and exit. Exit with -1. And if this happens, it shouldn't happen. If this happens, then we will investigate further. For now, it's fine. Pop stack didn't work. It should not happen, because when we are returning, let's just say there is only one operation, OP return. There is nothing in the stack. So pop stack doesn't work, or pop stack is empty. Exit. We will just exit. Okay. If it isn't, then we will print the bucket, whatever is in the bucket. So output. And also we have to give %f and new line. This is fine for OP return. Now let's just define the other cases. Case OP add. Okay. If we face OP add, what we will do, we will pop the stack 2 times. Like we will pop, because add is a binary operator, right? It needs 2 values. So we will pop it 2 times and then add it and then push it to the stack. Okay. So let's just make two buckets. Float bucket A, bucket B, and make it 0. Pop stack and machine stack, and provide that bucket A. Let's just assume, or we can do the same thing. Int all okay. Okay. All okay. And this we have to repeat it. If not all okay, pop stack didn't work. Exit, we will exit. Then again we will pop it. Same code. But we will provide bucket B. The pop stack will, what will it do? It is receiving the pointer. So it will just put whatever it's popping in this bucket. The variable is here. It is the bucket float. It is in this caller. This execute function is the caller. Execute is calling pop stack. So this where is it? This bucket A, bucket B is in the execute function, and we are giving it the pointer to that. Okay. Okay, so if it is all okay, then we will just push it to the stack by adding push stack and machine stack, and we will return bucket A plus bucket B. I guess that is add done. I hope you know understood what add is doing, and everything will be same. Let's just copy it. If it is sub, we will just minus. If it is mul, we will just return multiplication. Now the division part is interesting, and just handle it carefully, because division by 0 is a runtime error. We have to handle it. Okay, so see, in the stack, first we are popping bucket A, and then we are bucket B. But imagine if bucket B is later, we are later popping. So stack is a last in first out LIFO structure, right? So if we are popping A first, that means A was pushed last, that is after B. So logically A should be denominator, right? That is bucket A should be on the lower side of division. So we should check if bucket A is 0. If it is 0, we should raise an runtime error. We haven't defined the errors, but for now let's just exit, printing something. Okay, so bucket A, if bucket A is 0, bucket A is 0, let's just print Let's just say I can't do division by 0. Division by 0. Can you? Let's go sassy mode. Can you? Okay, and it will exit. And we will bucket B by bucket A. Bucket B by bucket A. Also, when we are doing the subtraction, it should be bucket B minus bucket A. Bucket B minus bucket A. Fine. Okay, so okay, multiplication, division, negation is incomplete, so let's just copy it. For the negation part, we will just keep it simple. We can optimize it, but let's just keep it simple for now. We will push we will pop the value, we will make it negative, and we will push that value. Let's just say negate. We don't need 2 buckets. We don't need bucket B. Bucket A. We don't need this. All okay. We will just push the negative of bucket A. Fine. Our simple small virtual machine is kind of done. So let's just execute the code. See what happens. So we are debugging the chunk. So the chunk is now 45, 36, add and return. It should return 81. Or simple. Okay, there is a chunk. Let's just define a virtual machine. Machine. Okay, we have to initialize the machine. Also, when we are going to execute, we should increase the instruction pointer. It is not needed right now because we are not using it, but later it will be needed. Instruction pointer plus, not here. Let's just wait a bit. We will do that. Instruction pointer is not necessary for now. So that let's write a init function. Init machine, and it will return nothing, void, and it will just receive a machine pointer. Okay, so for initialization, init machine, it will init the stack, I guess. Do we need to initialize the stack? No, I guess. Or yes, I guess. Code chunk. Yeah, we have to initialize the stack. Let's just write a init stack function. Void init stack. There is nothing to initialize, just init. We will init the float array. Init. We should name it float stack. You know what? So float stack name is fine. So we'll return we will accept a float start pointer stack, and we will just call init float array on the internal array function stack data. I guess that's fine. Init float array, and it float okay. Okay, fine. Now we can write the init machine part. In the machine there is only the chunk. The chunk part we don't have to write this now. We don't have to initialize it because we are providing it for when we are executing it. We have to init the stack. Init stack, and you know what init float stack it should be. Machine stack, it accepts the pointer, right? And also let's just make the IP 0, machine IP. Machine IP equal to 0, right? Okay, so init machine address of machine. Nice. Now let's just execute it. We provide the machine and the code chunk. Let's see what happens. Again, maybe we will get a seg fault, but our good old friend GDB is here. He will help us. Compiler error. Okay. Oh, there's a lot of error. 257 print. So that will be printf. 257 printf. Nice. One error gone. Okay. All okay. Redeclaration of all okay. Okay. So in the switch case, it is not. I guess it is not enclosed in this scope, so we have to omit it. The off redeclaration of all okays, that should be fine. A lot of the errors should be gone. Okay, bucket A, also buckets. We have to Remove the buckets. Okay. Why they're not scoped, man? See, what have you done? Anyway, in the OP return there is bucket. In the OP add, we are in. So these are not needed. Not needed. Not needed. The negation also not needed. So you know what? To make it easy for us, let's just take it to the top. No, whatever is necessary, it will be there. I guess compiled. Okay, so pop stack didn't work. Our stack is empty. Also, there is a lot of repetition of all. Okay, so let's just make a function for it. Check pop, I guess. Just void check pop. And there should be a message. No, there should be the operation. If not all okay, we will let's just print the OP with the okay, printf. And we print the OP here. Error, all okay. And OP. we have to find out on what operation the error is happening, or else we can't work. Same. See, here it was repeated 7 times. Then I'm replacing all the things. Until and unless there is at least 3 repetition, don't make a function out of it. No, okay, that's fine. Let's just compile it again, see if there is any error. Okay, check error has to be on top in the execute. It compiled. OP is 0, so there is addition. Okay, what is happening? Pop stack didn't work. Our stack is empty. OP is 0. Why it is 0? 0 is add. Let's go to that function and check it again. If stack data dot length is 0, return false. Okay, for debugging purpose, when we are executing something, let's just print that up. Okay, we know the code chunk is working fine, so let's debugging code chunk part is, let's just omit that, and in the execution, let's just debug things. Okay, in the load constant, let's just print load constant op load constant. In the op return, let's just print op return. Op return. In the add, same op add. In the sub, same thing. Sub. In the multiplication, op mul, and in the division, op div. Okay, the stream is going on for 2 hours. We have to end it. If I guess today it is till now, let's just say what is the Okay, so see, OP constant, OP load constant, OP add, OP sub. Why is sub happening? I didn't edit sub. What? Add and then return. It's why is there sub? Just complete it. Why keep it incomplete when we can do it? Let's just check it again. It's really sub. Ah, why is it sub? Load constant, load constant. Then we are adding. Stack bucket A plus bucket B. Okay, let's just end the stream right now. We will start right from here in the next stream, I guess. And the next stream will be, it may be tomorrow or maybe the day after tomorrow. To get notified, please subscribe and make the notification on so that you get notified when I schedule and I schedule a live. And this is it. Fine. Bye bye.